Okay guys, let's write your first Apache Spark program. And actually we'll use PySpark to do that. Okay, so let's start with just creating our folder to keep our code, all of our code that we'll be writing right now. Let's put it into just one place so we'll know exactly what it is. So I will create a new folder on the desktop. You can do it, in pretty much any place, but desktop is usually a pretty good choice. So yeah, my code, let's call it my code. And we'll be using the Jupyter notebook that we've installed in the last session to write our program. So the first thing that we need to do, we need to actually open a command line. Let's command prompt and go to our project folder. It's on desktop, right, and it's my code. Okay. And once we get there, we need to just type in Jupyter notebook, which will open a new Jupyter notebook in our browser. And Jupyter is pretty much just a you can treat it as code editor, interactive code editor. Okay, so we're basically inside this our project directory, and our PySpark, our first PySpark code will be actually counting a number of words in a text file. So what we need to do first, we need to create this text file. So let's click on the new and just choose text file, and you'll see that a new file appears, a new tab with a file you can type it in. So let's type in some text. Let's say hello world, hello Spark. Yeah, let's do just that, and let's change it to something that we short to use, wc.txt, right? So we can, short names are pretty cool in those kind of examples because we can quickly type them in. Okay, so let's click on file and save this file. So we can see that in our first Jupyter tab, you can see that this file is already there. Okay, so far so good. So we have our text file will contain a number of words in this file, right? So the next thing that we need to have, we can close this tab with the text file. It won't be needed anymore. Let's close it. Right now, the next step is pretty much to create a PySpark script, a PySpark script to actually do the work. So let's click on New again and choose Python 3. And this will open up Jupyter again, a new Jupyter tab. And this is, new Jupyter notebook is pretty much a just a file, a Python file, you can say. So Jupyter notebooks are not Python files, but we can treat them as such just for the sake of those examples. So let's change the name of the file, just the name of our notebook to, I don't know, let's say WC, right? Word count. Let's keep it simple. And Jupyter notebooks are pretty pretty useful to work with and pretty easy to work with. You're basically working with code blocks called cells, right? As you can see, our first block is pretty, it's highlighted, and you can just type in code and run this code interactively. So we can go step by step and type in the code, run it, see what we get. And that's basically, we can interactively work with this code. So, and you will learn how to use this Jupyter along the way. So don't worry about it. It's really easy to use. One thing to keep in mind is that if you want to run a specific cell, a specific code block, you hit either you click on run or you just hit Control Enter, which I will do because it's easier that way. Yeah. So yeah, and with plus sign we can add another cells if we want to separate them, because we can, each cell can be run separately. But that's for later. Right now, the only thing that you need to do is how to run a cell. So the first thing that we need to do to actually use PySpark, we need to create a new Spark application. So Spark application, it's really a new, a kind of a fresh access point to Spark functionality. We won't go into much details here, but the only thing that you need to know right now is that we need to initialize Spark session. So how we can do that? We need to import Spark session. Okay, so let's do that. So we need to import from PySpark SQL import Spark session, right? And let's run it. Let's click on run. Okay, so as you can see, I've run this cell, and on the left, if there's basically if there's no error after you run a cell, a block of code, it means that it's it's correct. And yeah, so this is our Spark session, and we'll be using it as our we can say that we will be using it as an entry point. But about that in a moment. So the next thing that we will actually need later on, but we need to import it as well. We need to import a add function from standard Python library. So from operator import add. And you will see later on how it's actually, why it's actually useful. But right now, those are the only two things that we need to import to actually, write our code. So let's run that. Let's hit Control Enter, or just click on the run, right? Okay, so there's no errors. It means that we can move on. And so the next step, so this is our first step, just the input the right stuff, the right elements that we'll later need to use and will actually use. So the later step, the next step is actually initialize, create this entry point, PySpark entry point. And this will allow us to use Spark API, PySpark API. So let's do that. So let's create this new variable called Spark, and this will be our entry point. We'll use this variable to access pretty much all of the functionality of Spark, right? So we need to initialize Spark. We need to initialize Spark session with it's actually builder with app name, call it WC, word count. So it's Spark session, builder, app name, get or create. Get or create. And this basically means is that if you can find a session, a Spark session already somewhere already in the system, please use that. Otherwise, just create a new one. So let's run that. Let's see how it goes. So I've hit Control Enter, basically run this. Okay, so our entry point has been created, right? Now we can actually use Spark functionality. And by the way, when I talk about Spark in this context, in this particular module, I basically I basically talk about PySpark, right? So, but it's just easier to talk about Spark. Use the Spark name to describe this functionality. Okay, so let's move on. After we create that, we can basically use Spark functionality, and the first step to create our script is to actually load our data. So let's do that. So our next step will be loading data. So let's click on plus sign, that means add another cell. And you can add as many cells as you want, and having separate cells, it's helpful because you can just run each cell separately, right? You don't need to run all of it at once. And it's useful when you develop your code. Okay, let's move on. So let's get our data into Spark. So step 1, S1, we'll use Spark functionality, which is Spark text read, and then this particular method, we have to provide a path to our text file, so which is it's in the same directory that we have our script. Let's have a look, right? So we have our notebook. Here it's wc.ipynb, right? And in the same directory we have wc.txt, right? Our text file that we want to work with. So this is basically the path to the file that we want to work on. And in this particular case, we want to count words in, right? So this is Spark functionality, Spark text read, and what else? So that's not all. This will basically create a pretty standardized data structure, but we need a little more. And meaning that this data structure that will be created here, called the data frame, is actually won't allow us to actually distribute the processing to a lot of to the whole cluster. So imagine that you have 100 computers, right? A Spark cluster that have 100 nodes, and we want to distribute this this processing over those 100 nodes. So we need to have some kind of mechanism that will allow us to do that. So Spark have this mechanism called RDDs. We'll get into more details about what are RDDs, but right now the only thing that you need to know is that this is the actual mechanism, the abstraction that allows us to distribute, process a lot of data, because it can be distributed into a lot of computers at once, and data can be processed in parallel. So we need to read our code, read our data, and turn it into those RDDs. So let's do that. So after we read this data, we need to turn it into RDD. And apart from that, we also need to do a simple conversion on this data. I'll explain that in a moment. So basically, we need to just strip it down, we can say. So here we've basically loaded our data into Spark, and then turn it into RDD, into the mechanism that allows us to distribute the processing power into many computers. And of course, in this particular example, we're just using our local computer, you're using your local computer, but if you would have more nodes, it will be distributed on more nodes. It will be processed on more than one node. And after we turn this data into RDD, we need to do a very simple data processing. So for each RDD, we need to strip it down using map function. So for each RDD, we're basically just choosing the first element. Right now, we don't really need to get into details. That's the preparation phase. The idea of these modules actually show you the steps that allow you to build PySpark scripts. So after we've done that, we can actually see how our data looks like, and we can do that using take method. And the first argument for take method is basically the number of data to get, and we basically don't have a lot of data, but we can get a snapshot. Let's say that we wanted 10 items there. I think that we got some error. Let's have a look. So Spark session. Okay, so I've misspelled some of this stuff. It's actually read text, right? So yeah, no worries. Okay, so this take method will basically give us a snapshot of it will give us a snapshot of the data. Those RDDs that are distributed in our cluster. So here we basically just have, at this point, we just have our data split into lines, right? So this is the first stage, splitting our data into lines. Okay, guys. So we will use, you don't really need to use take, but this is the way to actually check the progress you're making when you're building your PySpark script. It will allow you to see what's going on, how your data gets processed. It's the main way that you interactively build up your script. But you'll see how it works in a moment. I want to just show you how the data in each stage looks like. Okay, so let's move to the next stage. And by the way, you want to, from time to time, click on this save and checkpoint icon. It's a little diskette icon to save your code, right? So let's click on that. Okay, so what's the second step in our data processing? So if we want to actually count each word, we need to split it, split all of the data set into separate words, right? So this will be our second step. Second processing step, or third overall step. So how we can do that? We can actually do that quite easily. So the step 2, we'll use Spark functionality, very similar to the actual map function, but it's smarter version. You can say that it's smarter version of map. So map function, the standard map function in Python basically applies a function we provide for each element on a list, right? And flat map, which is a Spark function, will do the same, but if the data structures are nested, it will basically just create a one cohesive, one flat, you might say, data structure. Yeah. So let's do that and see what we will get, right? So right now we want to split this data set into separate words. So we're working on we will get the data from the first stage. So it's S1 and flat map. But this is our flat map function. And the first argument is basically, as with map function, it's basically a function that we'll use to split our words. So this will be applied to each RDD. So each element that you've seen here, it's actually RDD. Yeah. So this will be applied to each of these data step, each of these data item. Okay. So once we do that, let's see what we actually get. So let's have a look at our second stage. Right? Let's run it. Control Enter, or Control Enter or run, and we've got some errors. And let's have a look what we've missed. Okay, so we haven't actually split it. Let's do that once more. Okay, so it works now. I forgot that the argument for flat map and for this function is actually haven't provided the space, the separator that we need to provide for split. So basically what it does, it basically split each element on this in RDD, and basically we've got a list of words right now. Okay. So as you can see so far, we basically, what we're doing, we're just gradually processing each element, right? First, we basically load our data and just load it into the Spark, and get the for each line, just get the create a RDD for each line. Then we've created for each line, we've split each line into separate words. So right now, this is our data set. This is how it looks like. We have just a list of separate words. And by the way, here this what take show us is the actual representation of the data. And just keep in mind that those are RDDs. They are actually distributed. They can be distributed on a lot of nodes. But for the clarity's sake, it's really nice to see just the data without all of the mechanism and abstraction. Okay, guys. So what's the next step to count our worlds? We need to create some kind of way of tracking the number of words. We need to create some kind of counter for each word. So let's do that. Let's create new cell, step 3. So what we basically can do, we can then again use the data from the second stage, right? And we can create a simple tuple, right? And that will have the actual word and then the counter. Let's do that. So we will have our word and we have counter, and let's just set it up as 1 at the beginning. Yeah. So, and let's actually print what we've got here after this stage. Okay. So for each of this element, for each day of this separate item in this list, we've created a tuple out of it, right? So this is very interesting. As you can see, working with Spark is a little bit different than working with Python itself, unless you haven't been working with functional programming. It's a little bit it's a little bit different, right? So once we've created those counters, the next step would be to just aggregate them and just reduce the actual, or aggregate those words that are similar into one. And Spark has a very nice function to do that. It's called reduce by key. And this is where we will actually be using the add operator that we've imported at the beginning of this module. So let's do step number 4. So step number 4 will basically use reduce key, and so we will basically just use add. It's possible that we could use lambda, but we don't need to do that since we've imported the actual operator. So what reduce key? So it's reduce by key. Yeah, to be exact. Reduce by key. Reduce by key. Yeah. So reduce by key basically goes through each element, and you can say that is save it, right? So the first occurrence, so each unique occurrence is actually saved somewhere, and then it duplicates. When it's duplicated, the counters will increase. So it will basically look for similarities. We'll aggregate the similar keys and increase the counters. So let's look at what we have here after we've created, after we've used reduce by key. Yeah, so we basically got keys that we've got 2 hellos with 1, and they were aggregated into just one tuple with the same key, the world, and the counter was basically just increased, right? And the rest of the stuff stayed the same. So so we basically aggregated similar data into similar tuples into instead of having many similar words into just one. Okay, guys, so we're basically almost there. Our script is all almost correct, almost working. Well, it actually works, but we need to do some additional stuff if we want to actually use it on the real world data. So let's create another cell. And remember to click on the diskette to save here a code. So after we've done all this work and we see that it's basically working fine, what we, one of the last steps that we need to do is we collect all the data from all of the nodes. So we need to use a collect method. So let's do that. Output S4 is our last stage, and we need to do collect. And this will basically, I won't go into details right now, but we need to do that to actually make sure that we get all of the data that has been processed. So we need to do that at the end. Okay, so once we've done it, we can basically just show our output data. Yeah, so we can just go through, I'm sorry, we can just go through our output and print it, right? Basically just want to print it. Yeah. So we go through output and we just print it out, print each item in a separate line. That's basically what we are doing here. Yeah, that's what we're basically doing here. Let's run this code. Yeah, so it basically show us the actual word and the counter, how many occurrences we found in a text file on this particular world. And after we've done that, when we actually don't want to process this data anymore, we need to, say to Spark that we finished, that we want to just stop, right? So the last thing that you need to do in your script is to say Spark stop. So basically just do all of the cleanup, and we'll basically clean up our session. Okay guys, so as you can see, the steps are pretty easy. We time and time again use, in each step we use map, which is basically processing each item in the list and apply some kind of function to each element and add this new element that has been processed by this function. So we're doing what we've done here. If we basically done a lot of maps, and to actually create this, convert this data to the format that that can be used to aggregate this data, right? So you'll see this pattern time and time again. That's not the only pattern that Spark is using, but pretty much the most popular one. Okay, guys, that's it for now. Talk to you soon.